Hello everyone and welcome to week 3. I hope you had a good first couple of weeks. I'm going to get right into these examples. This week the topics we're going to cover will be absolute value, adding and subtracting integers, multiplying and dividing integers, and scientific notation. So we'll go through all of those topics through this video. Okay, so the first topic we want to look at is absolute value. Absolute value means the distance that a number is away from zero, regardless of what the sign of the number is. Absolute value is denoted by two bars. For example, these two bars here around the -5 means to take the absolute value of -5. And the absolute value of -5 is simply 5 because it's 5 places away from 0. So the absolute value of -5 is just 5 because it's 5 places away from 0. It doesn't matter about the direction. It just wants to know how far is the number away from 0. That's what the absolute value means. Another example would be to take the absolute value of 3. That's just 3 because 3 is simply 3 places away from 0. So again, absolute value simply means to find the distance away from 0, regardless of the sign. Okay, so let's look at adding integers. We have a couple of rules for adding integers. To add integers with the same signs, we would add the absolute value of the integers of the numbers, and we would keep the sign. For example, if I had two negative numbers, I will add the numbers together and I will keep the negative sign. To add integers with different signs, we find the difference of their absolute values and we take the sign of the number with the higher absolute value. So quite simply, we subtract the numbers and take the sign of the higher number. So we just find the difference of the two numbers, of the absolute value of the two numbers, and we take the sign of the higher number. Okay. Alright, so let's look at these examples on adding integers. If I want to add -7 plus -4, I would add the absolute value of the numbers and I would keep the negative sign. So we have the same signs here. So the absolute value, it would simply look like this if I wrote it all the way out. The bars meaning the absolute value. The absolute value of 7 is 7. The absolute value of 4 is 4. And 7 plus 4 is 11. But again, since I was adding two negative numbers, it's -11. It's kind of like a bank account. If you're -$7 in the hole in the bank account, and you spend $4 more out of that account, now you're $11 in the hole. Okay, so if you have the same signs, then you just add the absolute value of the numbers and we keep the sign. If we have different signs, then we find the difference of the absolute value of the integers and we take the sign of the number that had the highest absolute value. So in this case, I have -8 and 3. So since the absolute value of -8 is larger, then I know my answer will be negative. So all I need to do is find the difference of those, of the absolute value of those numbers, which is 5. But since my 8 had the negative, then my answer would be -5. Again, it's just kind of like a bank account. If you're -$8 in the hole and you deposit $3, now you only owe the bank $5. So you would just find the difference of the absolute value of the numbers and you would take the sign of the higher number. Okay. Subtracting integers. We have a couple of rules for subtracting integers, or we have one rule. To subtract the integers, we convert the problem to an addition problem, just like we looked at on a couple of slides before, by changing the sign of the number that is being subtracted. So we'll change it from, if it's negative, we'll make it positive. If it's positive, we'll make it negative. Then we can use those same rules that we just learned when we added the integers. So again, we convert the problem to addition by changing the sign of the number that's being subtracted. I like to call this keep, plus, and change. We keep the first number as it is, change it or convert it to plus, and then we change the sign of the number that was being subtracted. Then we use our rules that we just went over for addition. So keep, plus, and change. Keep the first number as it is, convert to plus, and then change the sign of the number that was being subtracted. Okay, so let's look at a couple of these. Alright, so we have 10 minus negative 15, and we want to convert this to an addition problem. So we're going to keep the first number as it is, keep 10 as it is, we convert that to plus, and we change the sign of the number that was being subtracted. So now the negative 15 becomes a positive 15, and that makes 10 plus 15, which we know equals 25. Okay, another example similar to that. Let's say we have negative 8 minus negative 3. So we're going to keep the first number as it is, negative 8. We're going to change this to addition, and we're going to change the sign of this number. So since it was a negative 3, it will now become a positive 3. And then we'll use our rules that we just learned. For addition, we have different signs, so we find the difference of the two numbers, which is 5, and we take the sign of the number of the higher absolute value. So since the 8 is has the highest absolute value, it will be a negative 5. Okay, so keep, plus, and change. Same thing with this one. Keep the first number as it is, change to plus, and we have to change the sign of this 5 to a negative 5. So now I have 12 plus negative 5. Negative 12 plus negative 5. And then we use our rules that we just learned in addition. Same signs, so we add the absolute values of the numbers. 12 plus 5 is 17, and we keep the sign, negative 17. So keep, plus, and change, and then you use your rules, the same rules that we use for adding integers. Okay. Multiplying and dividing integers. We would multiply and divide the integers. We do the calculations the same way that we always have, but we do have a couple of rules for determining what our sign should be in our answer. The first rule, if the numbers that are being multiplied or divided have the same signs, then like 2 positives or 2 negatives, then our answer will be positive. Second rule, if they have different signs, such as a positive and a negative, then our answer will be negative. So again, they have the same rules for the signs. If the signs are the same, answer is positive. If the signs are different, answer will be negative. Okay, so find the quotient. The key word, quotient, that means to find the answer to division. So this is telling me, the quotient is telling me to divide these two numbers. Find the quotient of negative 27 and 3, positive 3. So the first thing I notice is that they have different signs. I have a negative number and a positive number. So that tells me that the sign of my answer will be negative. It'll be negative 9. Okay, here, find the quotient of negative 12 and negative 4. This time I'm dividing two numbers that have the same sign. Both of these numbers are negative. So when I divide numbers with the same signs, then I just the answer is positive. So negative 12 divided by negative 4 will be positive 3. So different signs, negative answer. Same signs, positive answer. Okay, those same rules follow for multiplication. In this case, find the product, which is telling me to multiply, of negative 7 and negative 10. So negative 7 times negative 10. They have the same sign, both are negative, so I will multiply as usual, and my answer will be positive. Same signs, positive answer. Different signs in this second case, 11 times negative 5, is going to give me a negative answer, negative 55. Okay, so same signs, positive answer. Different signs, negative answer. And those rules follow for multiplication and division. Okay, special multiplication fact. Let's look at see if we can find a pattern with these problems here. If we multiply negative 2 times negative 3, we get positive 6. If we multiply negative 2 times negative 4 times negative 1, we get negative 8. Because if I multiply these two, that will make positive 8. And then positive 8 times negative 1 will give me a negative 8. Okay, if we multiply negative 2 times negative 2 times negative 3 times negative 5, using the rules that we've learned, we get a positive 60. Okay, if I multiply negative 1 times negative 1 times negative 1 times negative 1, that's 5 times there, we'll get negative 1. Now let's figure out the pattern we have. 2 negative numbers, positive answer. 3 negative numbers being multiplied, negative answer. 4 negative numbers being multiplied, positive answer. 5 negative numbers being multiplied, negative answer. So let's see, if we have an even number of negative numbers being multiplied, it's going to give us a positive answer, as we had here and here. And just the opposite of that, if we have an odd number of negative numbers that are being multiplied, it's going to give us a negative answer. So that's just a special little multiplication fact for you. Okay, let's shift gears a little bit and look at scientific notation. The scientific notation of a number is just a shorthand way to write a really large or really small number. Okay, so we want to convert a regular number into scientific notation. Our objective is to first move our decimal until there's just one non-zero number, and that number should be ranging from 1 to 9 on the left side of the decimal, and then write the correct exponent to represent how many times we move the decimal. Now we have a couple of rules for the signs of our exponent. If we have a number, a large number, or a number that is greater than 1 when we start out, then our exponent will be positive. So if our regular number that we start off with is 1 or greater, then our exponent will be positive. If the number we start off with is smaller than 1, then our exponent will be negative. So if the number that we start off with is greater than 1 or 1 or greater, then our answer will be positive. The exponent will be positive. If the number that we start off with is smaller than 1, then our exponent will be negative. Okay, so let's look at a couple of these problems. All right, we want to convert 256 million to scientific notation. So our objective, our first goal, is to get the decimal right here between the 2 and the 5, because that will give me that one number on the left side of the decimal. So I want my decimal to end up right there in between the 2 and the 5. And right now I don't see a decimal, so it's understood to be here at the end. So the first thing I notice is that this number is a lot larger than 1. So I know my exponent is going to be positive. So let's see how to write this. First of all, let's see how many times we have to move our decimal to get in between the 2 and the 5. 1, 2, 3, 4, 5, 6, 7, 8 times. Had to move it 8 times to get it in between the 2 and the 5. So the way I would write my answer will be 2.56, and I don't need the rest of those zeros out there, just the non-zero numbers there, times 10 to the 8th power. And it's times 10 because every time we moved it, that's a tenth. That's a 10. Every time we move it, that's a 10. Okay, so 2.56 times 10 to the 8th power, and it's positive 8 because the number we started off with was bigger than 1. And that will be our final answer. So again, our objective is to have only one non-zero number on the left side of the decimal here, and that number will be in range from 1 through 9, and then could be any number from 1 through 9, and then you would write times 10 to the whatever power, and the power represents how many times you move your decimal. Okay, so let's look at this number. This number is smaller than 1. It's 0.00000007. So that number is a lot smaller than 1 when I start off with 0 point something. So the first thing I note is that my exponent will be negative because I start off with a number smaller than 1. Now I need to move my decimal until I have one non-zero number, any other number except for 0, to the left side of my decimal. So in order to get that, my objective should be to move my decimal all the way over here until it's just on the right side of the 7. And then I'll have one number on the left side of the decimal. So to get it there, I need to move it 1, 2, 3, 4, 5, 6, 7 times. So my answer will be 7, because I don't have any other numbers out here, and just leave it as 7, times 10 to the negative 7. 7 times 10 to the negative 7. And again, it's negative because I start off with a number smaller than 1. This one up here, the exponent is positive because I start off with a number that's 1 or larger. Okay, so that's how you would convert to scientific notation. All right, let's look at just a few examples here, different types of problems. This one, find the value of negative 7 plus the absolute value of negative 3 plus the absolute value of 8. Now the first thing I would want to do is to get rid of the absolute value bars, which means I have to take the absolute value of those numbers that are inside there. So again, the absolute value is just the distance a number is away from 0. So the absolute value of negative 3 is just 3. The absolute value of 8 is just 8. Then I would want to combine my answers. So if I go from left to right, there's a couple of different ways you can do this. But if I go from left to right and combine those two first, remember my rule says if I have different signs, then I will find the difference of the two numbers, of the absolute value of the two numbers. So the difference between 7 and 3 is 4. And I would take the sign of the number that had the highest absolute value. So that would be negative 4. Again, I have different signs. So I will find the difference of the two numbers. The difference between 8 and 4 is just 4. And I will take the sign of the number that had the higher absolute value. In this case, 8 does, and it's positive. So my answer will be positive 4. Now note, one other way you could have completed this problem from that step, when you're just adding positive and negative numbers, is that you can add all of your positive numbers and get those into one big group. So I can add 3 and the 8 and make that 11, and then I can find the difference between the positive group and the negative group. So I have negative 7 plus 11. The difference between 11 and 7 is 4, and 11 was the bigger number and it was positive, so I still get the same answer, 4. So you can work that either way and still come up with the same answer, and that's just when you're adding positive and negative numbers like that. Okay, find the sum. Again, sum is a key word. It means to add. Find the sum of negative 17 and 15 minus 4. Now, we briefly looked at the order of operations in the last video, and the order of operations tells us to complete any operations inside a set of parentheses or enclosures first. So I would first of all simplify 15 minus 4, and we know 15 minus 4 is simply 11, positive 11. Next, I would combine these two using my rules for adding integers. I have different signs, so I know I have to find the difference of the two numbers. The difference between 17 and 11 is 6, and then I would take the sign of the number that had the highest absolute value. In this case, 17 has the highest absolute value, and it's negative, so it will be negative 6. Okay. Simplify negative 10 plus the absolute value of negative 8. Again, I would want to first of all get rid of my absolute value bars by taking the absolute value of that number. The absolute value of negative 8 is just 8. Then I would use my rules for addition to complete the problem. So I have different signs, which means first of all I need to find the difference of the two numbers, which is 2. And then I will take the sign of the number that had the highest absolute value, which in this case would be the 10 or the negative 10. So my answer will be negative 2. Okay, let's simplify this one. I have negative times the absolute value of 15 minus 2. So the first thing I would want to do is simplify inside this absolute value symbol. 15 minus 2 is 13. The next thing I would want to do is take the absolute value of 13, and we just continue to keep this negative on down here. The absolute value of 13 is just 13. But since I had a negative on the outside there, that negative would follow that answer on down to the end, and my answer would end up being negative 13. So the negative also means the opposite of. So if I take the absolute value of 13, the opposite of the absolute value of 13 is negative 13. So I would take the absolute value of this number, and then I would bring the negative sign down right beside it. Okay. How many negative integers are between negative 5 and positive 4? Keyword, negative integers. Integers, let's look at this. We have negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. It didn't say how many integers, it said how many negative integers are between. So that means we're not including negative 5. So my negative integers that are between negative 5 and 4 would be 1, 2, 3, 4. Those 4 integers there will be my negative integers that are between -5 and +4. So my answer would be 4, because there are 4 negative integers there between -5 and +4. So sometimes you have to kind of write those numbers out to see, to help you visualize and see what your answer should be. Okay, let's look at this word problem example. And I hope you all enjoy my attempt to draw this. I know we have a lot better drawers out there, artists out there, so y'all don't laugh too hard. It says my curtains run from the top of the window to the floor. So let's say we have a window here, and let's say we have some blue curtains, light blue curtains, and they run all the way down They have nice curtains, right? They run all the way down to the floor. So let's say my floor is here. And let's say we have a ceiling here, right there. All right, it says the window is 3 feet below the ceiling. So if I'm looking at it from the ceiling down, from here to here, we'll say that's -3 feet. 3 feet below the ceiling. And it says the measurement from the ceiling to the floor is 10 feet. So again, if I'm looking at from the ceiling down, from the ceiling to the floor is 10 feet. How long are my curtains? Well, it doesn't matter what angle I'm looking at this from. I'm just trying to figure out how long are the curtains. So as you can see, we clearly have to take the difference to figure out how long the curtains are. But the difference you take is going to be the difference of the absolute values of the numbers, because we want just a regular length of the curtains. So -10, take the difference of the absolute values of the numbers, which would simply be 10 minus 3, will tell us that the distance, or the length, I'm sorry, of the curtains would simply be 7 feet. So again, sometimes drawing the pictures out can help you figure out your answer. You can clearly see that if this is 3 feet here and the whole thing is 10 feet, then the length of the curtains would have to be 7 feet. Okay, hope you enjoyed the video. Hopefully those explanations and examples that we went over will be very helpful to you. Again, you've done a good job over the first couple of weeks, so let's continue that and have a good week 3. Okay.